All right, today we're diving into a tool called MemCloud, and it starts with a really simple but kind of mind-blowing question. What if you just never ran out of RAM again? It's a concept that could totally change how we use the computers we already have sitting on our desks. So let's get into it.
You know the feeling, right? We've all been there. You're deep in the zone, you're running a heavy build, maybe you're training a model, whatever it is, and then bam! Everything just grinds to a halt. The mouse starts beach balling, the fans kick into high gear, and your productivity just hits a brick wall.
And yep, this is usually the culprit. That dreaded red bar in your system monitor screaming that you're out of memory. Your machine is now swapping to disk, which as we all know is painfully slow. And the crazy part is, you probably have other computers just a few feet away, sitting there completely idle with tons of free RAM.
And that brings us to the core issue that MemCloud was built to solve. The creator calls it the stranded RAM problem, and it's a great name for it.
I love this analogy because it's just perfect. Having a whole network of powerful computers is like having a driveway full of cars, but you're still stuck. You can't get to work because the one specific car you happen to be sitting in is out of gas. All that potential power, all that memory on the other machines is completely stranded. It's right there, but you can't use it.
So what's the usual solution? Well, the conventional wisdom says to just go bigger. Buy a massive new machine with a ridiculous amount of RAM. But that strategy has its own problems. You end up hitting bandwidth bottlenecks on a single machine, and on those huge servers, you start running into things like NUMA penalties, where it's actually slower to access memory on a different CPU socket. So MemCloud proposes a totally different approach. Go wider. Instead of buying new hardware, you just pool the RAM you already have. This actually scales your memory bandwidth as you add more machines, and best of all, it uses the idle resources you already paid for.
So how do we actually do that? How do we unlock all of that stranded memory? Well, this is exactly where MemCloud comes into the picture.
In a nutshell, MemCloud is this super small, lightweight tool that creates a peer-to-peer mesh right there on your local network. It just automatically finds other machines running MemCloud and pools all of their unused memory together, creating this one giant virtual resource that any machine on the mesh can tap into when it needs it.
And the whole design philosophy is about making this dead simple. It's peer-to-peer, so there's no central server to manage or worry about. It uses MDNS for zero config discovery, which means you just fire it up and it finds its buddies on the network automatically. It works completely offline, no cloud accounts needed, and it comes with a command line tool and SDKs for Rust and TypeScript so you can start playing with it right away.
So the big question is, where does MemCloud fit into the grand scheme of things? This little chart is key. Look, it's not trying to replace your super fast local RAM. Nothing beats that. Instead, it creates a new warm tier of memory. Your local RAM has a latency of about 100 nanoseconds. MemCloud, or remote RAM, comes in at around 10 to 30 microseconds. Now, that sounds like a big jump, I know, but here's the kicker. A high-speed NVMe SSD is around 100 microseconds. That means MemCloud is still 5 to 10 times faster than swapping to your fastest disk.
Okay. At this point, I know what you're probably thinking, because I was thinking the exact same thing. Sharing raw memory across a network, that sounds kind of risky, right? So yeah, let's talk about security.
And it's a totally fair question. Isn't letting other devices access your RAM a massive security hole? We're not just sharing files here. We're talking about sharing the most volatile, most sensitive part of your computer's live state.
Well, the answer is that MemCloud was designed from the ground up with security in mind, specifically for the kinds of threats you'd see on a local network. As you can see here, it's built to handle the common stuff. It uses persistent identity keys so one machine can't pretend to be another. It uses encrypted proofs to stop man-in-the-middle attacks. It even generates unique keys for every single session to prevent hijacking. It's a whole layered defense system.
So let's peek under the hood for a second. How do two devices actually establish that trusted connection? It all happens in a process called a secure handshake.
This is basically a simplified version of it. You can think of it like a secret four-step digital greeting. Both devices exchange some temporary keys, and then they use those keys to send an encrypted proof of who they are, their permanent identity. And here's the important part. Both sides have to prove their identity to the other. If any part of that verification fails, the connection is just dropped instantly.
So what does this actually look like from your perspective as the user? MemCloud uses a really smart model called Trust on First Use, or TOFU. The very first time your machine sees a new device on the network, it's going to ask you, hey, should I trust this thing?
You have to explicitly approve it. After you do that once, it's remembered and trusted automatically. But, and this is super important, every single connection after that is still cryptographically verified to make absolutely sure it's the exact same device you approved.
Okay, so we know how it works, and we know it's designed to be secure. Now let's get to the really exciting part. What does a technology like this actually make possible?
And this is the killer demo, the real proof in the pudding. The developers actually ran a large language model on one machine and had it transparently use the RAM from a completely different machine on the same network. And check this out, you can see the proof right here. On the left, that's the Ubuntu machine running the AI model. But look at its local memory usage. It's super low. Now look over to the right. That's its macOS peer. You can see in the MemCloud stats that it's actively providing over 140 megabytes of its own memory to the Ubuntu machine. The AI is literally using another computer's brain to think. How cool is that?
And this really points to a much bigger, more fundamental idea. This quote nails it. When we stop thinking of computer memory as this private thing trapped inside one box and start seeing it as a shared resource on a trusted network, well, suddenly all these amazing new architectures become possible.
So what does that future actually look like? Well, imagine your CI build pipeline borrowing 100 gigabytes of RAM from all the idle Office PCs overnight to run some massive, complex build. Or picture a cluster of small, low-power edge devices pooling all their memory together to run an AI model that no single one of them could ever handle alone. It's about unlocking a huge amount of computational power from the hardware we already own.
And that really brings us to the final thought I want to leave you with. Just think about the projects you're working on right now, the bottlenecks you hit, the limitations you face every day, and just ask yourself this: what could you build if your computer's memory just wasn't a limitation anymore?